Hello everyone, welcome to Edexcel IAS for you. Today we can discuss section B of 2025 June Unit 2 chemistry paper. Let's move on to the questions. Question number 14. This question is about nitrogen, hydrogen and their compounds. Ammonia is produced in Haber process. Nitrogen and hydrogen react at a pressure of 200 atmosphere and a temperature of 725 Kelvin using an ion catalyst. Explain how a catalyst increases the rate of chemical reaction using the Maxwell-Boltzmann distribution shown and the collision theory. Alright, so what does a catalyst do to a reaction? So catalyst decreases the activation energy by producing an alternative pathway to the reaction. Right? So once the activation energy of the reaction decreases, the particle which having energy higher than the activation energy increases, right? So it's mean like this: the particles have energy. So once the activation energy decreases, so you can see this graph. So once the activation energy decreases, there are more particles that have ability to react, right? There are more particles that have ability to react. Initially, once the activation energy is this once it was low, there are less particles that have ability to react, right? But when the activation energy decreases, the molecules that have energy higher than the activation energy increases, so there will be more successful collisions per unit time, right? So there will be more successful collisions per unit time. So I mentioned here, the catalyst decreases the activation energy, so particles which have energy higher than the activation energy increases, therefore there will be more number of successful collisions per unit time. Okay, part B. Storing and transporting hydrogen can be difficult due to its low energy density. This has led to the use of various hydrates which contains high proportion of hydrogen and are easier to liquefy and transport. Explain the differences in the boiling temperature of the group 5 hydrates shown. Detailed description of the intermolecular forces are not required. Okay. First of all, we should see this graph and we can know that SbH3, which is antimony hydride, has the highest boiling temperature, and NH3 having the second highest boiling temperature, and ASH3 having the third, and pH3 is having the lowest boiling temperature, right? So next we have to know what are the intermolecular forces that these compounds are having, right? All of these compounds that are mentioned here are having London forces, right? Each of the compounds is having London forces, but additionally NH3 is having hydrogen bonds. Since its electronegativity is higher than the other elements in the group 5, it having hydrogen bonds, right? So hydrogen bonds are the strongest bond in this. Hydrogen bonds are stronger than London forces, right? Okay. So why SbH3 is having higher boiling temperature than the NH3, even though NH3 is having hydrogen bonds, which is stronger than London forces? So we should know that number of electrons increases down the group 5, right? So once the electrons of the compound increases, the strength of the London forces or London bonds increases, right? So strength of the bond increases as the electrons of the compound increases. Therefore, the strength of the London forces of SbH3 is higher than the hydrogen strength of hydrogen bonds and London forces. So it's having higher boiling temperature, right? So I mentioned here all hydrates are have London forces, but NH3 have hydrogen bonds. The number of electrons increases down the group. Therefore, strength of bonds also increases. So SbH3 has higher boiling temperature than NH3 since London forces of SbH3 is stronger than hydrogen bonds and London forces of NH3. Alright. Row number 2. Hydrogen has been proposed as an alternative fuel to petrol. Explain why hydrogen is more environmentally friendly fuel than alkanes. So we know that once hydrogen reacts with oxygen in combustion, it forms only water. But in alkane, in alkane combustion, it forms CO2 and H2. Right? So CO2 is a greenhouse gas which enhances the global warming. Alright, so I mentioned here hydrogen only produces water in combustion, but alkane produces both CO2 and water in combustion. CO2 is a greenhouse gas which enhances global warming. Right? So it's not environment friendly, but hydrogen is more environmentally friendly fuel than alkane. Right? Part C, ethylamine may be prepared from the reaction between ammonia and bromethane. State the conditions for this reaction. Right? So it's in your book. We need an ethanolic solvent for this kind of reaction to take place. Right. In Roman 2, complete the mechanism for this reaction. Include curly arrows, relevant dipoles, and lone pair. Right? You should keep these on your mind. Right? So NH3 is having a lone pair, so it attacks the carbon in the compound and it replaces the bromide ion. So once it is replaced, it is electron deficient, so it is positively charged. Another NH3 molecule which is having lone pair attacks hydrogen, and the bond pair of NH bondies break towards the nitrogen in the compound. So hydrogen is removed and NH2 is produced, and also NH4 plus due to the removal of hydrogen. In part 3, further substitution of ethylamine molecule may occur if the halogen alkane is in excess. State two features of ethylamine molecule that makes this possible. Right? So it contains nitrogen with a lone pair, and hydrogen attached to nitrogen can be substituted. Right? So it is more tend to react. Question number 15. The question is about reaction of some elements in group 7 when chlorine water is added to a solution of potassium bromide. A pale brown color is seen. Write an ionic equation for this reaction. State symbols are not required. Right? So we know that Cl2 reacts with 2Br minus ions to form 2Cl minus plus Br2 because Cl2 is more electronegative than Br. Right? Chlorine is more electronegative than bromine. Okay, part B, chlorine is used to treat drinking water. By considering oxidation numbers, show that this equation represents disproportionation reaction. Right? So what are the conditions need to disproportionation reaction to take place? Right? An element from a same compound should undergo both reduction and oxidation. Right? Element from a same compound should undergo reduction and oxidation. Undergoes both reduction and oxidation. Right? So by considering oxidation number, show that this equation represents disproportionation reaction. So we should work out here to find the oxidation number of chlorine in each compound. So we can find out oxidation number of chlorine in HClO is +1 and oxidation number of chlorine in HCl is -1. Right? So chlorine in Cl2 reduced from 0 to -1 in HCl. Also it oxidized from 0 to +1 in HClO. Okay, part C. Concentrated sulfuric acid H2SO4 reacts with solid potassium halide. Same observation are shown in the table. So we can see some observation with different halides, different potassium halide. In Roman 1, they are asking the equation for the reaction of concentrated sulfuric acid with potassium chloride is shown. State by this is not a redox reaction. Right? So once you work out here, you can find out the oxidation number of any element in this compounds in this reaction haven't changed. So oxidation numbers haven't changed between reactants and products. Therefore, this is not an example for redox reaction. Roman number 2, the half equation for the oxidation of iodide ions is shown. The half equation for the reduction of so they have given two half equation. The half equation for the reduction of concentrated sulfuric acid to hydrogen sulfide is shown. Deduce the ionic equation for the reaction between iodide and concentrated sulfuric acid by combining these two half equations. To combine the two half equation, we should remove the number of electrons from these two half equation, right? Since the electron number of second half equation is 8, we should multiply first equation from 4, right, to increase the electron number to 8, right? Therefore the electron numbers become spectator, so we can cut off we can eliminate electron number, so you will get this final ionic equation. Okay, Roman number 3 explains the differences in the reaction of concentrated sulfuric acid with chloride ions and iodide ions. So first of all, we should know that the size of ions increases down the group 7. Therefore, their ability to release electrons increases down the group, right? So that means electrons will be removed more easily, right? So therefore, reducing power increases down the group, and oxidizing power increases up to the group, right? Reducing power increases down to the group, and oxidizing power increases up to the group. So iodide ions are better reducing agents because electrons loses more easily. I've done a video about this part, test for iodide ions. I'll upload the link of that video in the below description, so refer that video to get more about this part. Question number 16. The question is about secondary alcohols. Give a chemical test including the result to show that alcohols contain an OH group. So this is easy, right? So we all know that we should add PCl5. So if OH is present, misty fumes will give an off. So what are these misty fumes? These are HCl misty fumes, right? So part B, a sample of cyclohexanol contains 7.13 grams of carbon, 1.19 grams of hydrogen and 1.58 grams of oxygen. Show that this data is consistent with the empirical formula C6H12O, right? So this is very easy. So you should have to divide the mass from the atomic mass, so you'll get the number of moles, then work out to get the ratio of the moles as I have done here. Then you will get this empirical formula which is consistent with the given empirical formula. Part C, Roman number 1. Cyclohexanol can be converted to cyclohexanone. Name the regions and conditions for this conversion. So this is the oxidation of the alcohol. So you should add potassium dichromate and heat it under reflux, right? Part 2, infrared spectrum of cyclohexanol is shown. Describe two differences other than the fingerprint region that would be expected in the infrared spectrum of the cyclohexanol. So most of students become frustrated with this word fingerprint region. So what is meant by fingerprint region in a spectrum? The region between 500 per centimeter and 1500 per centimeter of wave number in the infrared spectrum, right? So it between 500 and 1500, right? This part is known as a fingerprint region, right? So they are asking describe two differences other than the fingerprint region that would be expected in the infrared spectrum of cyclohexanol, right? So you should have to refer your data booklet and you can answer this question, right? So wave number range of 3750 and between 3200, which is responsible for OH bond, is absent. Wave number range of 720 between 1700, which is responsible for CO double bond, is absent, right? OH bond and CO double bond. Roman number 3, give a reason why cyclohexanol and cyclohexanone can be separated by fractional distillation but not by simple distillation. This is because the boiling temperature of cyclohexanol and cyclohexanone is almost same, right? Therefore, the boiling temperature of both, since the boiling temperature of both compounds is same, you should carry a fractional distillation instead of simple distillation, right? So I have mentioned the boiling temperature of both compounds is close to each other. That's enough. Okay, part D. Discuss the reaction between sodium hydroxide and 2-chlorobutane. The hydroxide ions acts in two different ways depending on the reaction conditions. Include the structure of four possible products, the reaction condition needed, and the roles of hydroxide ions. Right? Detailed mechanism are not required. So I have given here a flow chart, so you can easily get an idea about this question, right? So NaOH plus 2-chlorobutane. First of all, most of the students become frustrated with this sodium hydroxide because they have studied this part with using KOH, right? But NaOH and KOH is having almost same properties. Okay. The two conditions that this reaction undergoes is ethanolic. First one is ethanolic and other is aqueous, right? So let's talk about ethanolic condition first. In ethanolic condition, the reaction acts as an elimination reaction, right? Because the OH ions remove the chlorine ion from the compound and it forms an alkene, right? It forms a double bond between two adjacent carbon. So there are two possible products that forms in this reaction. One is butane 1-ene and another is butane 2-ene, right? But butene, the carbon in double bond of butene are having different groups in either side of the carbon, right? So it acts as cis trans isomers there, so there will be E-butene and Z-butene, right? So there will be three structures: but1-ene, E-butene, and Z-butene. There will be no cis trans isomers in but1-ene because there are same groups in first carbon of this but1-ene compound. Okay, the second one is aqueous condition. The aqueous condition, in aqueous condition, this reaction undergoes as a substitution reaction, right? Because OH nucleophile attach this carbon and replaces chloride ion with that OH, right? So it forms an alcohol. So there will be only one compound that forms here, which is butane 2O, right? Okay, so in writing part, the two conditions that this reaction can be takes place is aqueous and ethanolic condition. Ethanolic condition, the reaction is an elimination, and in aqueous condition, reaction is a substitution. So in aqueous condition, butane 2-ol is produced as the only compound. In ethanolic condition, but1-ene and but2-ene is produced. But2-ene shows cis trans isomers since there are different groups in either side of carbons in double bond. So it produces three different compounds, right? Altogether there will be four different structures. So you should have mentioned in the end of this question these four structures, right? These four structures you should have mentioned at the end of this question. Okay guys, I'm going to wind up today's paper discussion. I'll upload part C as soon as possible. So guys, thank you for joining with me. Bye. See you.